Hey folks, this is Dr. Humston. We're going to be looking today at section 2.2, navigating the periodic table of the elements. And this is part one of today's lecture. So first, the periodic table of elements. The inside cover of your textbook on the front shows a list of all of the elements, symbol, atomic number, atomic mass, but then it also has the periodic table of all of the elements with the same information, but because the table is structured and organized the way it actually reveals more information than simply a list, right? So we're going to learn how to make some sense of how to read the table, why things are the way they are, and what it allows us to know about an element based on where it is. So this is actually pretty amazingly created in this format in the 1800s by a guy named Dmitry Mendeleev. And this was before all the elements were even discovered. So they couldn't fill in every spot here, right? But because of the way it's structured, and we can see, we saw last time, right, that we can increase the number of protons as we count up. Even that wasn't even known yet. But what was known was that there were similar properties amongst elements, and they were grouped together to demonstrate that. And most remarkably, there were holes in the table for elements that had not yet been discovered, and there were predictions made about what those elements would be like, and when they were discovered, the predictions were correct based on their position in the table. So in navigating the table, here we're going to be looking at um, the significance of the rows and the columns, and how we can use them to obtain additional information about an element than simply what's given in the little box for each element. So this table here has a lot of extra information on it that we can begin to see what's going on. So we can look down a column at groups and learn about similarities within each column. And these are called families or groups. And we can look across a row and we see periods. And elements that are in the same group or family or column, such as this first column here, they all share similar physical and chemical properties, right? So lithium, sodium, potassium, rubidium, and so on all have similar chemical properties, similar physical properties. We're going to get to valence electrons and electronic structure and why they have similar properties, but for now, we need to just know that you can use information about a group to share uh, information about properties. So some things to notice just in the general structure and organization of the periodic table is that we have two columns here that are tall, and then 6 columns on the right that are tall, and a group in the middle that looks different. And the ones that I have circled here are called main group elements, and most of our focus is going to be on these. Now, the ones in the middle here and down at the bottom are still important, but they don't follow the rules quite as cleanly, and so we're not going to focus on them quite as much. Okay, we can see that these in the middle are called transition metals, and right here is something unique, right? So in fact, these two rows here fit right here, and if you look closely at the numbers, it goes from 57 to 72 because 58 through 71 are down here. So this is lanthanum element 57. So these are called the lanthanides, and they actually fit in here according to the true structure of the table and the periodicity. But imagine if they were actually drawn in there, the periodic table would be too wide and it wouldn't fit on posters in classrooms. So we just usually draw an arrow and the lanthanides are down here. Now they're still quite important. If you look down here, like uranium is down here, and some other heavy elements and the radioactive elements. But we're not going to really talk about those nearly at all. But notice that they are there and that they do fit in right here in the transition metals. So some of the main groups or columns have special names, and we can see those above the columns here. So we have column 1A as the alkali metals, 2A is the alkaline earth metals, and then 7A and 8A have names as halogens and noble gases. 3 through 6 do not have special names. Another thing to notice is that the A designation indicates the main group columns. And there are 8 of them. Okay, let's turn now to those 8 columns. And again, they have special names for some of them. Alkali metal and alkaline earth metals, which hints at metals being off to the left. And then 7A are halogens and 8A are noble gases. In the middle, what we're calling the transition elements often are given group names with B designation. And so these are the transition elements, and the bottom 2 rows are called the inner transition elements. And again, elements within a group share similar physical and chemical properties. And this reflects the periodicity of the periodic table, right? So periodic means like repeating in a regular pattern. And so as you go across a row, you'll experience each column or each group. And then when you get to the next period or next row, you'll go across the same groups and same properties in the same pattern. So to practice looking at a periodic table, finding elements, saying something about their group membership, here is practice exercise question 213. So for these 4 elements, state the group number and common name for these elements. So that the name of the group. All right. Well, the first thing is you have to find these elements. Okay, if I told you, look in group 4A, you would know where to look. But here, I'm telling you go find beryllium. So we don't know anything about where that is yet, right? But there is a hint that we're looking for group numbers and common names, and so we're probably looking at the main group elements. And basically, you'll get some practice and become more familiar with where elements are as you spend time doing problems like this. All right, so first we need to find them. So beryllium is here. And this table has the name and the atomic symbol. Some tables only have the symbol. It's helpful to have the name. So Be is beryllium. Iodine is just simply I, way down here, off to the right. Argon is right here. And nitrogen is N right here. So now that we've found them on the table, we can easily get the group number by looking to the top of the column. And if it has a common name, what is that name? Here we go. Beryllium is in group 2A and called the alkaline earth metals. Iodine is in group 7A and called the halogens. Argon is in group 8A and called the noble gases. and nitrogen is in group 5A, which does not have a common name in usage. So that's all about groups or columns, and the rows in the periodic table are called the periods. The periodic table itself contains 7 rows. We will focus most of our attention on the first 4. Period 1 only contains 2 elements separated at the edges for good reason we'll get to eventually. But that's hydrogen, number 1, and element number 2 is helium. And then once we get to element number 3, lithium, there are 8 elements. Period 3 also has 8 elements, 2 on the left, 6 on the right. And then once we get to 4, we now have a complete full row across. And so period 4 is shown here in the inset. And it has 18 elements. So in a similar way as before, it has the same 2 in the main group here. And it has 6 in the main group. So we have 1A, 2A, 3A through 8A. And then there are 10 that make up the transition metals. So a total of 18. Okay, let's wrap up this part with another question. This one's different. Here, I'm directing you to a place on the table and go find an element. Right, the previous question I said, where is this element? Which is a little bit harder. Here, you can think of the group and period kind of like longitude and latitude, and you can find, or x and y coordinates, and you can find the element. Okay, so group 2A in period 5. So here's 2A, here's period 5, so I can find it right there. A halogen in period 3. Well, you have to know which group the halogens are. If you can remember, halogens are group 7A. It says period 3. So they intersect right here. And then a transition metal in period 4. Okay, so we're looking here in this row. 2 more protons than calcium. This is kind of a different kind of question. So here's calcium and 2 more protons. Remember, a proton is the same as atomic number, and changing the number of protons changes the identity of the element. So 2 more protons would be moving to the right from 20 to 22, should be right here. So for A, we end up with strontium with symbol Sr. Halogen in period 3 is chlorine with symbol Cl. And a transition metal in period 4 with 2 more protons than calcium is titanium, Ti. All right, this will wrap up part 1, and we'll come back for part 2 to talk about metals.